Okay, so now next problem is where we are looking at some sentences, and there is a like a user specifications, which is saying that okay, you have two states, right? So two states means you have a ground state, which is q equal to 0 is floor 0. That's what it's saying. So let's say this is floor 0, right? And this is floor 1, right? These are the two states which you are having possible. Now, what is happening is when you have external input, which is m, right? So move here is an external input, right? Which is m. So then what happens is if m is 0, so that means we can now draw this like a state diagram, which we also discussed in the class today. State diagram is a way to understand or represent the user information. Whatever now user is saying, I'm just going to implement this on the state diagram. From the state diagram, then I will go to the state table. Okay. So what is saying is if it is m is 0, that means if m is 0, you stay there, right? Similarly, if your m is 0 here, you stay there. There's no movement, right? But if there is a m which comes from here, then you move to other floor, or the other way around. When you are at a floor 1, m comes, you move to this floor, right? That is what is happening. Okay. And what else? So this is the only thing, and there are two states which are 0 and 1 for us. So now this is the state transition diagram we have already made, right? So this is our 0th state and this is our 1 state. So that means if there is only one bit in the state, right? That means there are only two states. That means that we only can get away with just one flip-flop, right? We only need one flip-flop. Only one DFF needed, right? Because these are just two states which are just represented by one bit, right? So one DFF needed means that if I now draw the state transition table, so we see there is external input which is m, right? But there's a present state. Present state is now just described by q, right? Or qn, whatever is there qn, and this could be 0 or 1. Then there is a next state, which is what we are going to write based on this. But let's first populate the, because these are two inputs. So let's populate these two inputs, m and qn. So when we do 0, 0, 0, 1, 1, 0, 1, 1, right? These are the four possible combinations because there are two inputs. Um, then we look at now when m and qn are 0, 0, from the state diagram, what is that qn plus 1 should be, right? That is how we would know, now look at from this. Right? This would dictate this qn plus 1. So when we look at now, we see, okay, when we are in 0th state, and if m is 0, we are staying in there itself, right? So qn is basically 0, right? When we are in first state and m is 0, then we are staying in that state. That means we are staying in 1, right? Not moving anywhere. Now, let's say if you are in 0th state, when you are in 0th state and m becomes 1, then you see that you move to the other state, which is 1. If you are in one state and m comes as a 1, then you see that you move to the 0th state, right? So this becomes your next transition. Now you see this is what is our state table, right? Now if we want to make this circuit with d, because we know there is a d input which is there, right? So then we have to represent this as a d0 or d whatever, because there's only one d. And then you see for D, what D excitation table is very simple. And whatever you Qn plus 1 on the next state, that whatever is it is, that becomes the D input, right? So in this case, your D is basically Qn plus 1, which is 0, 1, 1, 0, right? So then in this case, then we see if we do the minimization of the Carnot map. So for Carnot map of D0, because that is the only input we have to find out in terms of what are the inputs of the state table, M and Q, right? So M and Qn, and we see this is 1 and 1, right? Which becomes, that means D0 is basically your M and XOR of Q. Let's say 0, 0, because that is the 0th bit and 1 bit only. So we can say this is at time t, this is 0 at time t plus 1, right? Which is the next state. So then we know that this is your input, which is like this. So then if one needs to implement this, we see, okay, This is your one flip-flop which I need. D0 input, Q0, Q0 bar. What I need is there is an external input M also, and this I have to do an XOR operation and feed that to the thing, and which input I have to do is external input, and the other input is coming from Q, right? So now with this, you would be able to see that you will be able to implement this kind of state table or the user problem of the elevator that with this circuit, right? Whatever we have seen. So that is also because here D0, this is your D0, which is M and Q, right? Q not XOR. Okay, so this is the one of the very simple example, and this becomes more and more complicated when complicated in the sense when there are multiple inputs and there are multiple states, right? So that because the number of inputs will increase. Here there were only two states. That means we could represent with one bit, right? That is what we saw, and that is why only one FF was needed. But if we have four states, that means that you will need two flip flops, right? Because now it is 0, 0, 0, 1, 1, 0. So those are four states which are possible. So that is how it goes about, right? Let's do the next one.